Today we will be discussing buffers and how to use Henderson-Hasselbalch equation. Buffers are solutions that resist pH changes because they contain hydrogen ions to neutralize the hydroxide ions and hydroxide ions to neutralize the hydrogen ions. Weak acids and conjugate bases form buffers for basic solutions, while weak bases and conjugate acids form buffers for acidic solutions. One example is ammonia and ammonium, in which ammonia is the weak base and ammonium is the conjugate acid. We will be doing a buffer pH calculation. The problem states, calculate the pH of a buffer that is 0.12 molar in lactic acid and 0.11 molar in sodium lactate. Now there are two methods we can use to solve this. We can either use the icebox method or Henderson-Hasselbalch equation. This is the icebox method. We begin by constructing an icebox in which I stands for initial concentration, C stands for change in concentration during the reaction, and E is the concentration at equilibrium. We fill in our equilibrium expression with products over reactants. The X stands for the hydrogen concentration, and this is the sodium lactate, and this is the lactic acid. Because the value of X is so small, we don't include it in our overall equilibrium expression. We find that the value of Ka from our reference tables, which is a constant, is 1.4 times 10 to the negative fourth, which means we only need to solve for the hydrogen concentration, which we find to be 1.5 times 10 to the negative fourth. Then we plug this into our pH equation, in which pH is equal to the negative log of the hydrogen concentration. Since our hydrogen concentration is 1.5 times 10 to the negative fourth, we find that our pH is 3.82. Now the icebox method is very long and sad because it takes so long. Although it does work, it takes longer and more work. The easier method is the Henderson-Hasselbalch equation. Henderson-Hasselbalch equation is pH is equal to pKa plus log of the concentration of the base over the concentration of the acid. Since we know most of our values, we can plug them in. We find that our conjugate base concentration is 0.11 molar of sodium lactate, and our acid concentration is 0.12 molar of lactic acid. But we need to find our pKa value before we solve for pH. To find pKa, we use the equation pKa is equal to negative log of the Ka. Therefore, we look in our reference tables. Since Ka is a constant, we know that it is 1.4 times 10 to the negative fourth. So when we solve for pKa, we plug it into negative log of 1.4 times 10 to the negative fourth. We find that the pKa is 3.85. Then when we plug this all in, we find that the pH is 3.82. Notice that the Henderson-Hasselbalch equation and the icebox method both yield the same answer. However, Henderson-Hasselbalch is more generally used because it's easier to plug in values. The end.